Welcome to the Deep Dive.
Great to be here.
This is the show where we take a whole stack of sources, could be articles, research papers, maybe even videos, like today, and we really dig into them.
Yeah, we pull out the key stuff, the really important insights.
Exactly. It's kind of your shortcut to getting properly informed, hopefully with a few surprises along the way.
And those aha moments, right? That's what we're aiming for.
That's it, moving beyond just the facts.
Trying to connect the dots, understand the why behind things, get the bigger picture.
Absolutely. So today, we are diving deep, really deep, into one of the strangest, most fascinating places in our solar system.
Which is?
Triton, Neptune's biggest moon. And it's pretty mysterious.
It really is.
We're using a fun what-if video as our launch pad today. And ask, what if you spent just 5 seconds on Triton?
Just 5 seconds sounds simple, but...
Right. But scientifically, the reality of those 5 seconds is intense, way more bizarre than you might think.
And that's what we'll do, sort the science fact from the, let's say, creative license in the video's idea.
Exactly. Because Triton is genuinely weird enough without making things up.
It's a fantastic way to explore a truly alien world, practically in our backyard, cosmically speaking.
And the video kicks off by highlighting something people get mixed up all the time.
Yes, the classic confusion.
Triton versus Titan.
Happens constantly. They sound so similar, it's an easy mistake to make.
They really do, like space twins or something.
Yep.
And the character in the video, Chase, he actually makes that exact error, navigates to the wrong moon initially.
He does, thinks he's gonna Titan.
So let's get this straight right out of the gate. They sound alike, yes, but they are totally different worlds.
Fundamentally different, worlds apart, you could say, literally.
Right, Titan orbits Saturn.
Which is about, what, 1.4 billion kilometers from the sun-ish?
And Triton, our focus today, orbits Neptune.
Which is way, way further out, around 4.5 billion kilometers from the sun.
Huge difference.
That distance difference is absolutely critical. It shapes everything about them. Temperature, geology, atmosphere, you name it.
Okay, so let's rewind to that initial mistake in the video. Chase thinks he's off to Triton, Neptune's moon. But his navigation system takes him to Titan, Saturn's moon. He even says, "Titan, my old nemesis." Thinks he's making a grand return.
It really drives home the scale, doesn't it? A simple typo in navigation, and you're billions of kilometers off course.
Billions with a B. So let's break down that cosmic geography a bit more. Titan around Saturn, 1.4 billion kilometers out.
Yeah.
Triton around Neptune, 4.5 billion kilometers out.
That's just their distance from the sun. The distance between them is even more mind-bending.
So when Chase realizes his mistake, the video says he's over 3 billion kilometers from where he needs to be.
3 billion kilometers.
That number is just hard to grasp. Earth is what, 150 million kilometers from the sun?
Roughly, yeah. Astronomical unit AU.
So 3 billion kilometers is like 20 times the Earth-Sun distance? Just wow.
An unimaginable gap.
And is that distance fixed? That 3 billion kilometers between Titan and Triton?
Ah, good question. No, not at all. That's where planetary orbits come in.
Right, because the planets are always moving.
Exactly. So that 3 billion kilometer figure, that's roughly the distance when Saturn and Neptune are relatively close in their orbits, kind of on the same side of the sun.
Okay.
But Saturn takes about 29 Earth years to go around the sun once.
A long time.
And Neptune, being so much further out, it takes nearly 165 Earth years.
Whoa, 165 years. That's a lifetime. More than a lifetime.
Precisely. So because their orbital years are so vastly different and their orbits aren't perfect circles, there are times when Saturn and Neptune are on completely opposite sides of the sun from each other.
Okay. Maximum separation.
Right. And when that happens, the distance between Titan and Triton can stretch to almost 6 billion kilometers.
6 billion, double the close distance.
Pretty much. Imagine planning that trip. Your travel time and fuel would depend massively on when you left, just based on where the planets happen to be in their super long orbits.
It's not like popping over to the next town. It's a multi-year journey where the destination keeps moving by billions of kilometers.
Exactly. It really sets the scene for how remote and isolated Triton is. It's not just another moon. It's way out there, defined by extremes.
Okay, so putting the Titan mix-up aside, let's focus on Triton itself. The video calls it gargantuan, colossal. How big are we actually talking?
It is genuinely big for a moon, especially one orbiting so far out. It's Neptune's largest, definitely. Diameter is around 2,700 kilometers.
How does that compare to, say, our moon or Pluto?
Good comparisons. It's actually a bit bigger than the dwarf planet Pluto, but slightly smaller than Earth's moon. Our moon's about 300 and 474 kilometers across.
Still pretty hefty. 7th largest moon in the whole solar system.
Right, the one. And its size matters. It suggests it could have enough internal mass and potentially heat to drive some interesting geology.
And the environment. The video mentions ice, glaciers. What's the temperature like and what's it made of?
Okay, brace yourself for the cold. It is unbelievably frigid. Average surface temp is around minus 235 degrees Celsius.
Minus 235 C. That's almost absolute zero.
It's incredibly close. Only about 38 degrees Celsius, or 38 Kelvin, above absolute zero, the coldest anything can theoretically get.
Wow. So what kind of ice are we talking about? Water ice?
Some water ice, yeah, but it's mostly nitrogen ice. Solid, rock-hard nitrogen, along with frozen methane ice, too.
Frozen nitrogen.
Yeah.
Like the gas in our air, but frozen solid.
Exactly. Imagine glaciers and mountains made of solid nitrogen. It behaves like rock at those temperatures. This icy composition is key to understanding some of its weirder features, like the cryovolcanoes we'll get to.
Okay, cryovolcanoes. We'll definitely circle back to that. But first, this next point the video highlights, this is where Triton gets really unique, isn't it? Its orbit.
Yes. The big one.
It's the only large moon in the solar system with a retrograde orbit. What does that actually mean?
Retrograde orbit. It basically means it orbits Neptune backwards.
Backwards?
Yeah, in the opposite direction to Neptune's own rotation. Think about it, almost all planets rotate in one direction, and most of their big moons orbit in that same direction, kind of like they form together from the same swirling disk of stuff.
Right, that makes sense. Prograde orbit.
Exactly. Triton completely ignores that. It goes against the grain, orbiting Neptune the wrong way.
So, if it didn't form with Neptune like most moons, where did it come from? The video uses the term kidnapped moon, captured from the Kuiper Belt.
And that is the leading scientific theory precisely because of that retrograde orbit. It's the smoking gun.
Okay.
The idea is that Triton didn't form around Neptune. It was probably a dwarf planet, maybe similar to Pluto, happily orbiting out in the Kuiper Belt, that big ring of icy bodies beyond Neptune. Billions of years ago, it must have strayed too close to Neptune, and Neptune's massive gravity grabbed it.
Just snags it out of the Kuiper Belt.
Pretty much. The kidnapped moon analogy isn't bad, actually. It implies a pretty dramatic, energetic event. It wouldn't have been a gentle capture. A lot of energy had to be lost for it to settle into orbit. Think cosmic wrestling match.
Wow. A captured world. And it's not just the backwards direction, is it? The video mentions its orbit is also super tilted.
Right. Another huge clue. Its orbit isn't just retrograde, it's tilted by a massive 157 degrees relative to Neptune's equator.
157 degrees, so it's almost orbiting upside down compared to Neptune's spin.
Exactly. Most moons that form with their planet orbit pretty neatly around the planet's equator. Think Saturn's rings and moons mostly flat, aligned. Triton's crazy tilt is more evidence that it was an outsider that got pulled in violently. Its initial captured orbit would have been wonky, very elliptical, and highly inclined. Over billions of years, tides have probably made the orbit more circular, but that extreme tilt is a leftover scar from its chaotic past.
Speaking of a chaotic past, this leads to another really dramatic idea in the video. Triton the moon killer.
Yes. It sounds like science fiction, but there's a solid theory behind it.
The video points out Neptune has way fewer moons than Jupiter or Saturn. Only 16 known moons for Neptune.
Compared to nearly 100 for Jupiter, and Saturn's pushing, what, almost 275 now?
Yeah, a huge difference. And Triton itself makes up like 99.7% of all the mass orbiting Neptune. It completely dominates.
That's utterly dominant. So the question is, where did Neptune's original moons go? Assuming it formed with a more normal set of moons initially.
Right.
The theory is that when Triton got captured, this massive object spiraling inwards backwards.
Going against the traffic.
Exactly. It would have caused absolute chaos in the existing system of moons orbiting the right way, prograde.
Like a wrecking ball through the system.
Pretty much. Its gravity would have massively disturbed the orbits of any original moons, kicked some of them out of the Neptune system altogether, maybe sent them flying off into space. Others might have been thrown into unstable orbits, leading to collisions, high-speed catastrophic collisions between moons.
So Triton's arrival basically cleared the house, either ejected or smashed Neptune's original family of moons.
That's the hypothesis. Over millions of years, the debris from these collisions might have formed rings, eventually rained down onto Neptune or scattered, leaving Triton as the undisputed king, plus a few smaller, maybe captured or resilient outer moons in weird orbits that survived the chaos.
So Moon Killer isn't just hyperbole. It reflects a plausible, violent history shaped by this one captured object.
It really does. It paints a picture of just how dynamic and frankly brutal the early solar system could be. The evidence is kind of in the abscess, the lack of large, regular moons you might expect Neptune to have.
Incredible. Okay, so this violent past, this extreme cold. But the video also brings up cryovolcanoes. Volcanoes on a place that's minus 235 C. How?
Yeah, it sounds completely backwards, doesn't it? But remember, they're cryovolcanoes, ice volcanoes.
Ice volcanoes, okay.
So they're not erupting molten rock, obviously. They're erupting mixtures of slushy nitrogen, maybe some water ice, methane ice. This stuff is called cryomagma.
Cryomagma.
Think of it less like Mount Vesuvius and more like an icy geyser. Something under pressure finding a way out.
An icy geyser. That helps. So what's providing the pressure and the heat if it's so cold?
Well, for the plumes Voyager 2 actually saw, the leading theory is surprisingly simple. Sunlight.
Sunlight. But Neptune is so far from the sun.
It is, but the sunlight, faint as it is out there, can still penetrate the top layer of nitrogen ice, which is pretty transparent.
Okay.
And it can warm up darker patches of material just underneath the surface, maybe dust or organic stuff.
Mm-hmm.
This slight warming causes the nitrogen ice right above the dark patches to sublimate, turn directly from solid ice into nitrogen gas.
Like dry ice on Earth, solid to gas.
Exactly, and that gas builds up pressure in pockets under the surface. Eventually pop. It blasts out the slushy cryomagma, nitrogen, ice particles, maybe some methane in these huge plumes.
How huge are we talking?
Voyager saw plumes shooting up to 8 kilometers high. That's like 5 miles straight up into Triton's thin atmosphere.
Wow. Driven by faint sunlight. And this process resurfaces the moon.
Seems like it. The material falls back down, creating those dark streaks Voyager saw. It implies the surface is relatively young, geologically speaking, constantly getting paved over by this icy volcanic fallout. We even saw features like the Leviathan Patera, which looks like a collapsed cryovolcanic caldera.
So it's not necessarily deep internal heat driving these specific geysers, but solar interaction.
For these plumes, that seems to be the best explanation, yeah. Although, as we'll get to, there probably is internal heat deeper down. But these surface features seem linked to sunlight, and it's rare. Only a few places like Earth, Io, and Enceladus show current volcanic or geyser activity. Triton's in a very exclusive club.
Okay, a dynamic, icy, volcanic world. Now let's get back to the what-if premise. 5 seconds on the surface without a suit. The video paints a horrifying picture. What are the immediate dangers?
Horrifying is the right word. It's instantly lethal, multiple ways. First off, the atmosphere.
Right, it has one, but...
But it's incredibly thin. About 70,000 times thinner than Earth's atmosphere at sea level. It's practically a vacuum.
So thin, it might as well not be there, from a human perspective.
Pretty much. It's mostly nitrogen, like ours, but with bits of methane and carbon monoxide probably vented from those cryovolcanoes.
And the video mentions boiling. Your saliva and tears boiling away. How does that work in the freezing cold?
Yeah, that's the Ebelism effect. It's not boiling from heat, it's boiling from the lack of pressure.
Oh, wow.
Liquids boil at lower temperatures when the pressure drops. On Triton, the pressure is so incredibly low, the boiling point of water, or the moisture in your body, drops way below freezing. So the liquid water in your eyes, mouth, lungs, even skin moisture would instantly flash boil, or technically sublimate, turn straight to vapor.
So you're freezing and boiling at the same time. It's nightmares.
It's a deeply unpleasant thought experiment. And that's just the start. Then comes the explosive decompression the video mentions.
Right, what happens there?
The pressure difference between the inside of your body, especially your lungs filled with air, and the near vacuum outside is immense. Your lungs would rupture almost instantly.
Oh, God.
Air bubbles would form in your bloodstream. You'd lose consciousness in probably less than 15 seconds due to lack of oxygen and pressure. Severe tissue damage, ruptured capillaries. It's over very, very quickly.
So those 5 seconds are generous. You wouldn't even be conscious for that long.
Not even close. It just highlights how utterly dependent we are on pressure suits and life support in such environments.
Okay, so atmosphere is instant death. What about gravity? The video mentions that's also a hazard.
Yeah, another danger that sounds counterintuitive. Triton's gravity is super weak, only about 8% of Earth's.
8%. So if I weigh, say, 150 pounds here.
You'd weigh about 12 pounds on Triton.
Wow, you could jump really high.
You could. Maybe meters high with a little hop. Which sounds fun, but it means there's hardly any friction keeping you grounded. A small misstep, a trip, pushing off slightly too hard.
You just float away?
or start tumbling uncontrollably. Voyager saw a really fractured, messed up surface, rifts, ridges, pits, weird terrain. Imagine trying to walk on that, where one wrong move sends you drifting slowly towards an icy chasm with no way to stop yourself.
Because there's not enough gravity to just fall down quickly and stop?
Exactly. You just keep going. You could tumble for ages across the ice plains with almost nothing to slow you down. Navigating that surface would be incredibly difficult and dangerous, even with a suit. You'd need specialized gear, maybe tethers or thrusters.
Okay, deadly atmosphere, treacherous low gravity. It's not exactly welcoming, but the video teases something hidden, an ocean, under the ice. How is that even possible?
Right. This is where Triton gets really exciting from an astrobiology perspective. Despite the surface being colder than cold, the theory is strong that yes, there could be a layer of liquid water hidden deep beneath that massive ice crust.
Liquid water? How? Where's the heat coming from?
Not from the sun, obviously. The heat source is thought to be internal, coming from Triton's core. Scientists model Triton as having layers, kind of like an onion, a dense core, probably rock and metal, then maybe a rocky mantle layer above that, and then possibly a liquid water ocean sandwiched between that rock layer and the thick ice shell we see on the surface.
And the heat.
Radioactive decay. Just like inside the Earth, heavy elements like uranium, thorium, potassium, trapped in the rocky core when Triton formed or was captured, decay over billions of years. And that decay releases heat.
Enough heat to melt water ice way out there.
Potentially, yes. If the core is large and dense enough, the slow trickle of radiogenic heat over billions of years could be sufficient to maintain a liquid layer beneath the insulating ice crust.
Wow. And if that ocean touches the rock below?
That's the key part for life. If the water is in direct contact with the rocky mantle, you could have chemical reactions. Minerals leaching into the water, providing chemical energy and nutrients. You'd have the three key ingredients often cited for life: liquid water, chemical building blocks, and an energy source.
Life. Could there actually be life swimming in a hidden ocean on Triton?
It's purely theoretical at this point, of course, but it's plausible. We're not talking complex creatures like the video joke's about, probably.
No tritonic shrimp.
Haha, probably no tritonic shrimp. But simple microbial life. Organisms similar to extremophiles we find on Earth in deep-sea vents or under Antarctic ice, surviving on chemical energy instead of sunlight. That's definitely within the realm of scientific possibility. If the ocean has been stable for billions of years, who knows? It's one of the most compelling targets for future exploration.
A hidden ocean, potentially teeming with microbes. Amazing. Now, the video also draws a comparison. Triton and Pluto, space twinsies it calls them. How similar are they, really?
That comparison got a huge boost after the New Horizons flyby of Pluto in 2015. It revealed stunning similarities.
Like what?
Well, they're very close in size, mass, density. Their surface temperatures are nearly identical, extremely low. Both seem to have formed in the Kuiper Belt.
Okay, similar origins make sense if Triton was captured. But more than that.
Oh yeah. Both have surprisingly active surfaces for being so far out and cold. We see evidence of ongoing geological processes. Both have vast plains and glaciers made of nitrogen ice.
Nitrogen glaciers, like rivers of solid nitrogen flowing slowly.
Exactly. Moving over millions of years, carving features. And crucially, both Pluto and Triton are now thought to potentially hide those subsurface water oceans we just discussed.
So they really could be siblings, or at least close cousins, from the Kuiper Belt, sharing fundamental characteristics.
It strongly suggests they represent a class of large, icy bodies formed in the outer solar system with complex histories and maybe even similar internal structures. It makes studying one tells us a lot about the other and about the Kuiper Belt in general.
And visually, the surface. The video mentions cantaloupe terrain. What on earth is that?
Yeah, cantaloupe terrain. It's one of the most distinctive and weirdest surface types seen on Triton by Voyager 2.
It looks like a cantaloupe melon.
Pretty much. To the Voyager scientists back in '89, these large areas covered in pits and dimples, separated by ridges, looked remarkably like the textured skin of a cantaloupe. These features are big, maybe tens of kilometers across.
Any idea what causes it?
Still debated. That's why it's so interesting. One idea is diaperism, basically. Blobs of slightly warmer, less dense ice slowly rising up through the colder, denser ice crust, like a super slow-motion lava lamp.
Okay.
Another idea is collapse. Maybe areas where subsurface material, like nitrogen ice, sublimated away, leaving voids that the overlying crust collapsed into. Or maybe it's related to cryovolcanism somehow.
So it's a geological puzzle box.
Exactly. It tells us something complex and dynamic is happening or has happened within Triton's ice shell, but we don't fully understand the process yet. It's just weird and unique terrain.
All these theories, these incredible details, they all come from basically one quick look, right?
That's the really crucial context here. Everything we know up close about Triton comes from a single flyby, Voyager 2, back in August 1989.
One brief encounter.
One brief encounter. It zipped past, took photos from about 40,000 kilometers away. Amazing for its time, revolutionary images. But it only managed to image about 40% of Triton's surface in detail. Less than half. The rest is literally unmapped territory.
So over half the moon, we just have blurry, distant views of, or nothing at all.
Pretty much. And think about 1989 technology. This was before the Hubble Space Telescope was properly working, before the internet as we know it, before the high-res cameras we have now.
Yeah, ancient history in tech terms.
Right. Triton was actually the last big thing Voyager 2 looked at before using Neptune's gravity to fling itself out towards interstellar space. It was an incredible achievement, but it left us wanting so much more. We've learned enough to know it's incredibly complex and potentially habitable, but we're basing that on data that's now over 30 years old and covers less than half the globe.
It really puts it in perspective. So much speculation built on such limited data.
Exactly. Imagine what a modern orbiter or lander could discover there. It's ripe for a return mission.
So let's wrap this up. We've journeyed out to this bizarre moon, Triton. We started with the confusion with Titan.
Worlds apart.
Worlds apart. We look at its colossal size, its unbelievable cold, that defining retrograde orbit pointing to its capture.
The kidnapped moon scenario.
And its potential moon killer past, reshaping Neptune's whole system.
Yeah, pretty dramatic stuff.
Then the cryovolcanoes, those icy geysers powered by faint sunlight.
Resurfacing the moon constantly.
The instantly lethal atmosphere, where your tears would boil from low pressure.
Not a fun 5 seconds.
And the treacherous low gravity, combined with that fractured, maybe cantaloupe skin terrain.
Making even walking around a huge challenge.
Beneath all that hostility, the tantalizing possibility of a hidden ocean.
An ocean of liquid water, possibly in contact with rock, potentially harboring life.
It's just an incredible bundle of contradictions, isn't it? So cold, yet active. So distant, yet potentially holding ingredients for life.
It really is. And connecting it all, Triton is just this amazing example of the sheer diversity out there in our own solar system. We think we know planets and moons, but then you get something like Triton that breaks the mold.
Captured worlds, weird orbits, ice volcanoes.
Exactly. And even with that one brief glimpse decades ago, science has pieced together this incredible story. It really shows the power of observation and deduction, but also how much more there is to find out.
And like that what if video, our whole deep dive today is really driven by curiosity, isn't it? That basic human urge to ask, what's out there? And what would it be like?
Absolutely. And then using science to try and find the real answers, separating the plausible from the purely fictional.
So keep asking those what if questions.
Yeah.
Keep looking for good sources. Stay curious.
Definitely. And maybe think about this. Given everything we suspect about Triton, especially that ocean, what's next?
What would it take to go back?
Yeah. Not just fly by, but really explore.
Yeah.
An orbiter, a lander. Maybe something that could drill through kilometers of ice to actually reach that ocean.
Wow. The technology required would be immense.
Huge challenge. Nuclear power, robotics that can survive minus 235°C, autonomous systems. But imagine the discoveries. Finding life there would rewrite everything.
It really would. And maybe Triton isn't unique in being a captured world with secrets.
Exactly. What other objects out there, maybe in the Kuiper Belt, maybe even rogue planets between stars or moons orbiting distant exoplanets? What secrets are they hiding?
Makes you wonder what else is waiting to be discovered.
The universe is full of potential deep dives. We've barely scratched the surface, even in our own neighborhood.
A fantastic thought to end on. Thanks for diving deep with us today.
My pleasure. Always fascinating to talk about Triton.